Now, suppose I have the following data on a student population and pizza sales. So imagine that this is a list of a restaurant chain. There are 10 restaurants in the chain, and we like to find the relationship, or we think there's a relationship between the local student population size and the sales of a pizza. And so we do a scatter diagram, and we'll plot each of these data. So for example, the first observation, right, is here, and this is 2 comma 58. Right? So there's 2,000 students in this town, and there are 50, and our quarterly sale is 58,000. Okay. Now clearly, once we plot it, we see that okay, there seems to be a linear relationship. That as the more student, that's the larger the student population in a town, the higher the pizza sale, the higher the expected sale that we would have. All right. So then our model, right? So we have the data, and here our model is right. It's yi equals beta 0 plus beta 1 xi plus epsilon I. Or in another word, we're saying that the sales, right, equals beta naught plus beta 1 of the times the population plus epsilon I. Right? So sales can be written as a function of the population. Okay? Now, our estimated, our regression equation, right, then is expected value of yi equals beta 0 plus beta 1 xi. No epsilon because this is an expected value. So that is the line that will explain the relationship between the two. This again, right, because it has beta in it, we call this the true line or the true regression equation. Right, that is that line here. Okay. Now the question is which line is it? Right, we don't know. Right, we assume that there is a line that can describe the relationship between x and y. We just don't know which line is that. So we would like to estimate it. So the estimated simple linear regression equation then will be sales hat. Right, the estimated sales equals this equation b0 plus b1 times the population. Right? Right? In other words, y hat I equals b0 plus b1 xi. Okay? Right? The way we read this is we could say, right, given the student population, right, what is the expected sale. All right, expected, and we're going to use the word expected and average interchangeably. Oops, gosh. So the next question is how to calculate B0 and B1, right? And again, there is no one right way. Right? There are many ways you can do this. Right? We can take a look at this. Or we can say, well, I can, and maybe for most of you, right, once you see this data, right, you might say, well, how about if I just connect the first point and the last point here, and then I can make a line going this way. Right? And that could be true, and this looks like it's a line that could explain this too, right? But for example, what if this last point is down here? What do you do, right? Obviously, if I draw this line here, then that's not going to represent the data too well, right? Or I could pick these 2 points. Right, let me use a different, let me just use the same line here. I can use these 2 points and I can draw a line. And that line could also potentially, right, be a pretty good line to represent the data. Right? So which line should I use? Okay, again, these are just estimates, or I can use either one. So how about, well, let's go have the first one and the last one. Right? Let's find the equation of that line. Okay, so now we're gonna use some basic algebra skills. Right? So I have 2 points. So point number 1. Change the color. Point 1 right, is 2 comma 58, and I'm going to go ahead and use the last point, because remember from your algebra class that you only need 2 points. You only need 2 points to make a line. Okay, so my last point here is 26 comma 202. Okay, so I have these 2 points, and once I have 2 points, then I can create or I can calculate a B0 and B1. Now here, I just want to show you as an exercise, show you an alternative way to do this. Now you don't ever have to do this because we're not going to do it this way, but I just want to go through it. It should be, it's kind of interesting. We can use algebra to create to run a regression essentially. Okay, but then later on I'll explain to you why this is not what you want to do. Okay, all right. So a quick algebra refresher. Right? Our goal, like to create a line with 2 points. All we need is this. This is called the point slope formula. M times x minus x1. Right? And then so now first thing we need is the slope. Well, here we go. Slope, remember, is rise over run. Right? Now if I take the 2 points, then is 202 minus 58 over 26 minus 2. So this gives me 144, that, and gives me 6. So my slope is 6. Once I have the slope, all I need is one of the points to plug in, and I can finish my equation. So I'm going to go ahead and use the first point here. Okay, and then I just go ahead and distribute. Right, do a little quick algebra. Y minus 58. And then this gives me y equals, right, 6x plus 46. Right? Or if I write it, or I can write it like this. Y equals 46 plus 6x. Right? Now here then, this is my B0. And this is my B1. All right, so that is an estimated, right? That is so this here is my estimated simple linear regression equation. Okay, nothing wrong with this, right? This is perfectly fine, right? And it will give me going through this process, right? Will allow me to arrive at an estimate for B0, for beta 1. I'm sorry, beta 0 and beta 1, right? My estimate. Here we go. My estimate. Right? For beta 0 is 46, and estimate for beta 1 is 6, right? And there's nothing wrong with this, okay? Well, there is, but technically it's not wrong, but it's not efficient. Why? Well, the intuition that you want to have whenever you do statistics is, can I utilize more information? Right? And in general case, you want to use as much information as possible. And here, the problem we have, intuitively speaking, the problem with this line, even though this could be the right line, but the problem with this line is I'm only using 2 data points. I'm only using 2 observations. I have 10 restaurants, but I'm only using 1 and 10, right? And there must be some information that the rest of the restaurants, the rest of the observations can give me, and I'm simply tossing them out, right? And that simply is not efficient. Right? So you want to think about, well, is there a more efficient way? Is there a better way that can improve my accuracy? All right, and it turns out there is, right? And that's what we will use instead. Okay.